First of all, thank you, Cadence, for giving a wonderful introduction about us. So we'll start with introduction about myself. I am Abhay, leading Audit and Assurance at CRED, formerly known as Dreamplug Technology Private Limited, a fintech in India. Basically, it's a platform where actually we used to provide the payment for the credit card. It's a multiple credit card where we can do the payment at once.
Yeah, thank you, Abhay. Good afternoon, everyone. I'm Dhananjay. I take care of technology risk and compliance at CRED. We deal with regulators and security standards like every now and then. Our primary job is to ensure all the products are baked with compliance and security first approach. So today we're going to talk about mobile payment security, what are the new risks, what are the vulnerabilities, and how to overcome those challenges. So mobile adoption has increased over last 2 decades, and with the same pace now, the mobile payment has also increased rapidly with the age and so the mobile payment brings speed, drive the global growth. Mobile payment market grew from $920 billion in 2020 to $5 trillion. This is nothing but the 25% of the annual growth rate. With such convenience, introduce the unique risk beyond the traditional system. With this explosive growth, now the core challenge is how to solve the mobile-related security problems. So in this session, we're going to talk about what are the vulnerabilities of the mobile systems, how to identify, how to mitigate those, and seamless authentication approach for the same. What do you, Abhay?
All right. Thanks, Dhananjay. Like Dhananjay told that we are actually going to discuss about the latest trends or latest threats with respect to the new trends, what is actually evolving here in the new era of mobile technology. So here actually we have divided into 3 categories. One is device-centric, then software and hardware-centric, then user behavior. Now in device-centric, we actually try to understand what kind of a risk which is actually available, that is lost and stolen device, from where actually, let's assume that you have lost your device and an attacker can directly gain the access of that particular payment system which is installed in that particular application or the mobile. The second one is your rooted device. Let's say nowadays, I've seen that in multiple markets like US or European market, they don't have any specific standards which actually talks about that you should not use a rooted device, where actually they can directly install any malicious APK and which can be compromised by attacker. The next one is there's a weak device security. That is, let's say the user wanted to keep a password and it's a repeated password which they wanted to use, and again, that can be compromised with the attacker. Second one actually is a software and hardware risk where public Wi-Fi vulnerabilities, where all the people use public Wi-Fi and that is not very secure, and that is very vulnerable for all the users. Like any attacker can do a man-in-the-middle attack and also eavesdropping. Then again, some of the app-specific vulnerabilities leads to insecure coding practices and data leakages from the app storage. Then next is the phishing attack and social engineering, where mobile-tailored attacks like phishing and social engineering are increasing day by day, like SMSing. You have encountered multiple scenarios where you would have received a multiple SMS stating that, okay, you won a lottery or something like that, where you actually get into the trap of the attacker and you try to give all the information, sensitive information to that particular attacker, where they gain all the accesses like PAN, CVV, PINs, etc. Next one, again, we are going to talk about user behavior risk. That depends on the user, how exactly they are going to behave with respect to their mobile. And when the user is actually using a mobile, let's say the older mobile, or they are installing some of the applications from non-trusted sources. Okay, let's say I try to send you an APK, and you directly download it from the untrusted source or from the website instead of the App Store or Play Store. Okay? These are the APKs, or these are the malicious APK which can gain the trust, gain the PIN or your CVV and all those details from the user. Coming to all the users have the tendency to ignore all the, the security updates which is actually available in the market, or let's say for the mobile. They try to skip that particular thing or delay that update for the mobile, which actually leads to the compromised mobile. Again, similar way, like I told you that people have the tendency to use weak passwords, like they used to keep a password like 1234, which is very guessable. So that's why these are the threats which is actually available in the market, and attackers try to use the same. Then now we can now talk about threat actors, in action, which is actually increasing day by day in the market. Some of the threat actors like Telegram-based RAT. RAT is just a remote access tool where malicious APK disguised a legitimate app like QR payment, cashback offers, where a user gets trapped, and exploit permission to read SMS, capture screenshots, and log keystrokes, silently exfiltrate stolen data via Telegram Secure API, and which is very hard to trace for any of the forensic investigator or something. And then coming to the next, fake customer support app scam. This is also a very big scam, which actually, there has been a report as well, as per the FBI IC3 report. Tech scam losses somewhere around 1.46 billion in 2024, and which has been increased close to 500 million from its previous year, that is 2023. That is a drastic increase and explosion, I can say, in the scam. Next is a QR scam on the social engineering, where fraudulent QR codes used to redirect your payment, and scammers sends fake collect requests to get all the inputs from you, like PIN, CVV, and all the sensitive details. Okay. In the similar way, these are the technical exploits which is targeting mobile payment application integrity. That is, the first one is abuse of accessibility service that allows a malware to read screen content and simulate user action, like all the PIN entry or the CVV which you are going to enter into that particular application. The next one is UI deception attack or overlay or tapjacking, which basically malicious app tricks user into interacting with the fake UI element and to steal all the inputs or to approve unauthorized payments. Insecure data storage and clipboard hijacking, sensitive data, credentials, or token secured unencrypted in the device, and that has been stolen from the device itself. Or let's say if you are storing into the clipboard, let's say whenever you're doing a copy paste, that has been stored in the clipboard, that also is going to get stolen from the attacker. Now the next one is improper intent handling or intent hijacking. With this, malicious app exploits insecure inter-app communication to the initiate unauthorized action or intercept data like OTPs, or again CVV or anything. The next one is outdated malicious third-party SDK vulnerability introduce backdoor data risk. In the similar way, we can talk about the evolving threats with respect to the AI and biometric vulnerabilities. Now, with the adoption of the new hardware modules and cutting-edge technology, new threats and risks are evolving. In the biometric authentication weaknesses, insecure fallbacks where app allows switching from biometric to PIN without verifying the device lock or the user intent. Then next one is lower-end devices still can be fooled by photos or videos. Let's say some of the user wanted to use the application, or let's say that their device is a little bit old. They can still get fooled by the scammers, where they'll just showcase your photo and get the access of that particular mobile. And blind trust in the device level results app accept system biometric success without verifying the session's integrity. Emerging AI threats, like I guess in the previous sessions also, we have seen that AI is evolving like crazy, and all the people are just running behind the AI. Now, in the similar way, deepfake and voice phishing is also one of the latest threats and evolving threats towards the AI, where AI tool mimic the voice of the bank officials to trick the user or just to approve the payment, or they just wanted to get the OTPs, which has actually been transferred to the AI agent, and that has been taken by the attackers. An AI-driven malware and smart rats, that again, remote access tool, malware uses AI to evade detection, mimic users, and gestures. Dynamically, they can just adapt, or they can just get all the details from your mobile, and they can do all this unauthorized transactions.
Yeah. So Abhay has explained what are the threats, threat exploits, and risk around the technologies, mobile payments. Now we're going to talk about how to solve this. The risk everyone knows, but the solving is very important. So in our organization, we took certain steps to identify that these are the risks and how we can solve it. So certain key principles we identified. One is minimizing attack surface, which is nothing but implementing secure code practices or minimum permission to the application. The second is protecting sensitive data by implementing robust encryption, tokenization payment system, etc. Then secure authentication and access control, which gives very robust security to the system by implementing multi-factor authentication, tampering protection by detecting and preventing unauthorized software implementation, secure updates, which many times are delayed or neglected by the developers because of the productivity or business impact, which is very critical. The next and last and the most important is logging and monitoring, which is bare minimum requirement, not just from the audit perspective, but standards, forensics, every aspect, which is very important to ensure that all these key requirements are implemented. These requirements we baked in as a part of software development practice itself, where we call it as a secure by design, compliance by design, or privacy by design. These practices are derived mostly, these key principles are derived from the PCI SSF framework only. So now we're going to discuss more about how these key principles are aligned with PCI SSF framework, and we'll see some of the practical implementation as well, which we have implemented as a part of our journey of building the payment wallet in our organization. So PCI SSF, most of you guys are aware that what is PCI SSF. It's nothing but a mobile security framework designed to help software vendors as well as the organization deploy, distribute, and maintain the payment applications. It focused mainly on two parts, development as well as deployment, which is the unique thing. It's not just focusing on the development part, but deployment is also as important as the development, which has two main core components. One is secure software lifecycle, SLC. The other is secure software standard. The importance of PCI SSF lies into its role to ensuring the payment software built and maintained with the strong security controls to protect sensitive payment information such as the card data, CVV, all those information. It helps reduce vulnerability, mitigate the risk, facilitate faster and more efficient compliance certification. At the end of the day, the first thing is to ensure the compliance is there, and with the same time, we have to also ensure security is also there. So if we are making PCI SSF framework as a part of software development lifecycle itself, then it will ensure both the things. First is it will help you to reduce and mitigate the attack surface. The second, it will help you to reach your compliance attestation certificates very fast. Then the third is it also helps organization to evolve regulatory standards, evolve and implement regulatory standards, and deal with the emerging security threats in the digital payment ecosystem. Now we'll see some of the practical implementation. So we already talked about the lack of biometrics and lack of AI-related control implementation. So first, we're going to talk about the advanced device binding. Device binding is a requirement where it is mandatory for many parts of the world, but it is not mandatory across the globe. And how we can leverage the device binding as a functionality or the requirement. Here we rely on the two important things. One is the leveraging the hardware security. Now with the new technologies or the new hardware upgradation, the hardware itself has a lot of new features coming up. Some of them has already explained in the previous discussions about the new HSM and all those things. So we relied on the two important things. One is trusted execution environment. In iOS, there is a Secure Enclave where we segregate the keys from cryptographic keys from the cryptographic operations, which helps us to isolate both the things. The second is from the Android perspective, Android key attestation, we are verifying key-based, key-backed hardware and device integrity. These both things we integrated with the SIM-based authentication. So there is a one-to-one mapping with user, device, and SIM, which gives a strong user identity, which is aligned with the PCI SSF control objective of authentication and authorization. So creating a robust cryptographic link between user, SIM, and the device. This is what we have achieved by implementing the hardware-based security. Next is we'll talk about multi-layer authentication. So authentication or multi-factor authentication is always there. It's not something new which we have implemented, but we relied same as the previous one, where we discussed about the advanced device binding. We relied on the hardware-backed the infrastructure, where the first is leveraging the PKI, public key infrastructure, where we use the digital certificates and cryptography both to ensure non-reputation of authentication and critical sensitive transactions, such as payments, integrating PKI to store into the hardware-based link to the biometric, where only the user's biometric will have access to the Android KeyStore or iOS Secure Enclave, which helps prevent from attacker to have access to the sensitive information such as the keys. These things are, again, aligned with the PCI secure authentication and access control. A multi-layer approach is used to verify the user identity and authorize the payment transaction. The second is sensitive data protection and runtime security. With the implementation of multi-layer architecture, multi-level authentication, we achieve this data sensitivity and runtime protection as well by encrypting the data on device itself, instead of storing on the server and encrypting the data at the server level. All the sensitive data is stored into the mobile device itself and encrypted using the user's private key. We use the PKI, public key infrastructure. The user install all the private encryption key within the device itself. Next is tokenization.
Yeah, so next, like Dhananjay talked about the different implementation, what we have achieved into our organization with the help of PCI SSF. In the similar way, this is the third one which we would like to discuss here, and we would like to tell you how exactly we have achieved the tokenization into our day-to-day life for the mobile applications. So basically, for the protecting payment data at rest and transit by replacing payment data, that is PANs, with non-sensitive and with the unique tokens, which is actually provided by, which can be generated randomly, and that token can be stored into the Android KeyStores and iOS Secure Enclave. So Android KeyStore is basically, you can securely store the cryptographic keys for tokenization operations, okay? And the second one is the key can be hardware backed and strongbox, key mint, or TE for the strong extraction resistance, which require a user authentication for the key access. In the similar way, for iOS Secure Enclave, dedicated hardware module for the cryptographic key storage and operations are used, and keys are isolated and ensuring that sensitive data and protections during the tokenization. Now, benefit for this mobile payments, significantly it will reduce your PCI DSS scope and in the mobile application as well. And the similar way, by the help of using PCI SSF, again, you can just develop that particular system or the application for the mobile. Directly, now for the PCI SSF, when we are talking, directly address the protection of stored card data and encrypt transmission during the requirements. Next one is how we are going to maintain the user experience for the mobile applications. Let's say these are some pointers, that is biometrics, offers basically the primary authentication method, which is both fast and intuitive. Let security mechanism like tokenization and device binding operate invisibly and seamless background process. It's just like a magic to user. They will just do a transaction, and in the backend side, all the tokens will get created and will get stored into the secure enclave. Now, the next one is prompt contextual authentication only for an extra verification when risk dictates a high volume transactions or a new login. The clear and concise communication, educating user on purpose of the security measures, that we always have to educate our end users how they can secure their data like this. And the frictionless enrollment, streamlined process for initial setup and security feature activations.
Yeah. So these are some of the learnings while we implemented the framework at our organization. So these learnings are common for across the industry. One is new threat requires new defense. Mobile payment introduced the unique dynamic threats, which required specialized security strategy using cutting-edge technology like implementation of machine learning, LLM. Some of them we discussed in yesterday's discussion of vulnerability management as well. The second is seamless authentication is a strategic imperative. So by leveraging advanced control of PKI, hardware-based module, SIM binding, all these controls, it gives a frictionless experience to the user, but at the same time provide the strong security for the mobile ecosystem. The last and most important is security by design is the now key requirement. You can't think after fact. You have to, while making the product, you have to think about security first to ensure that security will also help you into implementing privacy and compliance. That's why secure by design is very important. Thank you.